Yeah, good evening. Good evening, children. Good evening, online students. Danya and Krish Ritik. I've shared my screen. Visible, online students?
Yes, ma'am.
Yeah. Yeah, this is the first question for today's class. Read, I'll give you about 10 minutes. Try and then we'll see the answer. Yeah. Good evening. Just a minute. Okay. Or maybe we'll do this one together. The figure alongside, it's actually below, it's not alongside. Okay, so the figure below shows the path of a diver. It shows the path of a diver when she takes a jump from the diving board. All right. Clearly, it's a parabola. Okay. You can see the image there. Annie was standing on a diving board 48 feet above the water level. So she's just in position now. Annie's just taken the position. So she's not attempted to dive. She's still, so she that the time now is 0 seconds. The time now is 0 seconds. Okay. The height of the diving board from the water level, from the surface of the water is 48 feet. The diving board is at a height of 48 feet above the water level. The diving board, correct? Okay, so she took a dive into the pool. Her height in feet above the water level at any time t in seconds. Time t, the variable t represents the time in seconds, not in minutes or hours, in seconds. The variable t represents time in seconds. Okay, so her height in feet above the water level at any time any time t in seconds is given by the polynomial h of t, such that h of t is equal to minus 16t squared plus 8t plus k. Fine, let's not read ahead. Let's understand what actually is given so far. So we have this quadratic polynomial h of t. H of t is the quadratic polynomial, right? H of t is the quadratic polynomial. Now, and the polynomial is minus 16t squared plus 8t plus k. So now t is the time in seconds. T is time in seconds. All right. Now, when you for different values of t, now when you substitute values, when you give different values for t, you get a value for the polynomial, right? That value represents the height of the diver above the surface of the water. See, when you give a value, you get a value, right? So what does it represent? What does the value you input represent? What does the output value represent? When you substitute some value for t, you get a new value, right? So what do we understand from these two values? So the value of t which you given is the time. Okay, and the result, 1 second, let's just take an example. Now, supposing we say we take t as 1. Now this is incomplete because we don't have a value for k here. We have to find the value of k. We have to find the polynomial is incomplete in the sense the value of k is not known. We'll have to find that. But otherwise, when you give a specific value for t, you get a value for the polynomial, right? That represents the height of the diver above the surface of the water. So on the x-axis is the time, and on the y-axis is the height of the diver at a given time. X-axis, time. Y-axis, height of the diver at that given time. All right? Okay. So when you give a value of t here, that is the time. 0, 1, 2, 3, 0 seconds, 1 second, 2 seconds, 3 seconds. So when you input t as 3 seconds, the value you get on working, the value you get is the height of the diver at 3 seconds above the surface of the water. All right, that's the relation here expressed in this quadratic equation. Okay, I think we'll understand better once we finish answering all these sub questions. So this is about Annie. Okay, this is the quadratic polynomial. Now read the question. What is the value of k? So that's your first question. What is the value of k? Yeah, we were saying no that k is, you need to get the value of k. This is incomplete otherwise. So that's what you'll have to first find. What is the value of k? Now to find the value of k, we know one thing already. That is, we know one x value and one y value already. What is the x value we know? When time is 0. The y value we know is 48. Because when she's on the diving board, okay, when she's on the diving board, she's not attempted to dive, right? So time is 0 seconds. Time is 0. So when time is 0, what is her height? 48 feet above the surface of the water. See, this here we are bringing the relation between time and height. That's all, only these two things. Time, height. When time is 0 seconds, what's the height? What is her height, Annie's height from the surface of the water? 48 feet. How do we know that? Because the diving board is 48 feet above the surface of the water. These are the two quantities in relation here. Okay. Time 0 seconds. Height 48 feet. So when t is 0, the value of the polynomial is 48. When t is 0, the value of the polynomial will be 40. H of t will be 48. 48 is on the y-axis. See, x-axis is time, y-axis is the height. Now, we know two things here already. That is time 0 seconds, height is 48 feet. Yeah, so we are going to use this information to find the value of k. And t is 0 seconds, okay? H of t, the value of h of t is equal to 48 feet. Okay, so what is given? H of t is equal to h of t minus 16t square plus 8t plus k. Yeah, h of t is equal to, yeah, h of t is equal to 48 feet, right? The value of h of t is 48 feet, so 48. And how do you find h of t? 1 second. Sorry, children, just give me a minute. Yeah. So when t is 0, h of 0, when t is 0, the value of h of t is 48. When the value of t is 0, so h of t, right? H of 0, t is 0. H of t, h of 0. So t is 0. What is the value of h of 0? What's the value of the polynomial? It's 48. That's how we represent 9th standard. So h of 0 is equal to 48. That is when t is 0, the value of the polynomial is 48. Okay, so now how do you work h of t? In the polynomial, wherever we have t, we'll have to use 0. So minus 16 plus 8 into 0 plus k is equal to 48. H of 0, this is how we work. In the polynomial, wherever there is t, h of t, right? See, this h, don't get confused with h. That's the way we name a polynomial. How do you name a polynomial? You can call it p of x, q of x. This h has, this, it can be anything. It can be a of x also. I'm sorry, a of t also. T is the variable. This letter has got nothing to do with any understanding. In the bracket is a variable, t. Okay. So this is 0, 0. So k is equal to 48, right? K is 48. So the value of k is 48. Yeah, C. Next one. At what time will she, is the first one okay? Yeah, the next one. At what time will she touch the water in the pool? So again, think of the relation between time and height. That's all. Time, height, time and height. Now, when her feet touches the water in the pool, what's the height? 0 feet. When she's high on the diving board, her height is 48 feet. When her feet touches the surface of the water, her height is 0 feet. See, height is calculated from the surface of the water, not from the bottom. Not from the bottom of the swimming pool. The height here in this polynomial is calculated from the surface of the water. So surface of the water, when her feet touches the surface of the water, the height is 0 feet, right? So h of t, the value of h of t is 0. The height is 0. Then what is the time? You should find the time. You must find the time when the height is 0. Yeah, we'll do that. But before that, we'll have to construct the polynomial. So what is a polynomial? H of t is equal to minus 16t square plus 8t plus k. So that is equal to minus 16t square plus. See, there should be only one variable in the polynomial. There cannot be any other unknown, right? So we have to use the value of k and complete the polynomial before you use the polynomial for further calculation. Only one unknown t can, the variable can be there, which is t here. 80 plus 40. This is the polynomial. This is the polynomial completely. Now we'll answer the second question. Okay. So here, what's the height? Why? Because her feet touches the surface of the water. So height is 0. Height is 0 meaning the value of h of t is 0 feet. The value of h of t is 0 feet. But for what value of t is it going to be 0? That we don't know. That's what we have to find. For what value of t? In the first case, we knew both. In the first one, we knew both. That is when time is 0, her height is 48. We knew both there. When t is 0, h of t is 48. Here, we only know h of t. We only know the height, 0 feet. At what time will her height be 0 feet? That we don't know. That we have to find by using the polynomial. And for that, the polynomial should be complete in every sense. Meaning that that k's value should have been found. And we already found it, so we've completed the polynomial. So now h of t is equal to 0. So h of t meaning, what is h of t? Minus 16t square plus 8t plus 48 is equal to 0. H of t is this one only. This only is h of t. This one only is h of t. This one. This is the polynomial. So h of t is 0. That means minus 16t square. This one is equal to 0. So solve this. You can divide by 8 throughout. You can divide by 8 throughout. So you get minus 2 plus plus 6 is equal to 0. Please solve this and bring the two values of t.
T is 2 and minus 3 by 2, ma'am.
Yeah, I'm not solving it. What are the values of t? Yeah, Danya?
Minus 3 by 2 and 2.
What?
Ma'am.
Minus 2. Rendu minus na end value edukku. 2.
Plus 2, ma'am.
T is 2. Okay. Okay. All of you got this? Okay. Okay, let's do it then. So split the middle term. 4 and 3. Plus 4 minus 3. Plus 4 minus 3. Correct? 3 and 3 by minus 2, minus 3 by 2. Yeah. So minus 3, time cannot be negative. So we ignore that and we take the positive value. So the time is 2 seconds. So that means what? What do we understand? Touch the. So from the diving board, when she takes a leap, it just takes 2 seconds for her to touch for her feet to touch the surface of the water. Yeah. So but the answer is B, 2 seconds. At what time will she touch the water in the pool? The answer is B, 2 seconds. All right. Next one. Rita's height in feet above the water level is given by another polynomial. Rita's height in feet above the water level is given by another polynomial. The diving board is there only. The diving board is at a height of 48 feet from the surface of the water. But she'll have a different curve, a different polynomial, right? So water level given by another polynomial P of t. T time. So T is T, P of T, just to differentiate the polynomials, P of T, with zeros minus 1 and 2. The zeros of her polynomial are minus 1 and 2. Then P of T is given by. So you should find Rita's polynomial. That is, you should find the polynomial which will help you to find Rita's height at any given point of time. Yeah. All right. So we'll just take her zeros, P of T minus 1 and 2. minus 1 and 2. So how do we construct a polynomial given the zeros? Louder. The variable is t here. It's called what? Q of t. Yeah? P of t. P of t. Yeah. So P of t is equal to. How do you find the polynomial? T plus 1 into t minus 2. The product of the factors. The product of the factors. If minus 1 is a 0, then t plus 1 should be a factor. If 2 is a 0, then t minus 2 should be a factor. Or you can use the standard form x t square, that is x square minus sum of the zeros into x plus the product of the zeros. You can do it that way also. Or you can, this also, right? When you know the zeros, you can find the factors. The product of the factors will give you the polynomial. So if minus 1 is a 0, then take the opposite sign. T plus 1 will be a factor. If 2 is a 0, then t minus 2 will be a factor. Why t? Because the variable is t here, time, t seconds. Whatever is the variable. Minus 1 means t plus 1. Plus 2 means t minus 2. These are the factors. Okay. And not this alone, into k. You know that, right? So P of t is equal to k into, see, there can be more than one. We know that more than one quadratic polynomial can have the same number of zeros, same value for zeros. Now minus 1 and 2 can be the zeros of different polynomials. Can be the zeros of different polynomials. So you should find the specific one here. So k into, so P of t is equal to k into t plus 1 into t minus 2. Now, is this understood? The product of the product of the factors, when the zeros are given, minus 1 is a 0, t plus 1 is a factor. 2 is a 0, t minus 2 is a factor. The product of the factors will give you the polynomial, and to get the specific polynomial, multiply by k. All right. Okay. All right. Now, so this is equal to k into t square minus 2t plus t minus 2. T square minus t minus 2. Okay. What's the question? Yeah, you need to find the P of t. So now we need to find the value of k. We need to find the value of k here also. So now what is, when time is 0? When time is 0, what is our height? Same thing. Everybody, all of them, when time is 0, height will be 48 feet. That is for everybody who stands on the diving board. When time is 0, height is 48. What is it? 48 feet. Yeah. So what is P of t here? P of t is equal to 48. P of t represents the height. P of t represents the height. So P of t is 48 feet. What is P of t? K into t square minus t minus 2 is equal to 48. And what should be the value of, when it is 48, what should be the value of t? 0. When it's 48, the value of t is 0. So k into 0 square minus 0 minus 2 is equal to 48. So I think that'll be 2k is equal to 48. So k is equal to 24. Sorry? Oh, minus 2k. Thank you. Minus 2k. So minus 24. Okay. So zeros are given. So with the zeros, we found the factors. The product of the factors into k will give you the specific polynomial, quadratic polynomial. All right. Now there, we have not still found it completely because we have to find the value of k. And it's always easy to find the value of k because we know two things. When time is 0, height is 48. When time is 0, height is 48. We know these two values. So it's easy to find the value of k. So how do we do that? P of t represents the height. What is the polynomial given by P of t, right? So P of t is 48 feet. P of t is this polynomial, this one. See, this P of t only is this one. So P of t is 48. That means k into t square minus t minus 2 is equal to 48. Now take t as 0. T as 0 and work that, you will get the value of k. So k is minus 24. Now complete the polynomial. So P of t is minus 24 into t square minus t minus 2. So the polynomial for this person, I forgot her name, minus 24 minus 24 t squared plus 24 t plus 48. Yeah. And what is this person's name? Rita. You can even reduce the number of steps. You just write it like this. You can directly do this if you don't want many steps. Okay, so the zeros were given. We found the polynomial. And to find the value of k, we use those two things, 0 seconds, 48 feet. So 0 seconds should be used in place of t. And the value of the polynomial is equal to 48. The 0 is the value of t. When t is 0, the value of the polynomial is 48. So the polynomial is p of t, right? P of t. So for t, if you give 0, p of t is the polynomial. No, see the board. P of t is the polynomial. Now for t, if you give 0, P of 0, that value will become 48. Yeah. So P of 0 means what? In the polynomial P of t, wherever there is t, you should put 0. P of 0 means in the polynomial P of t, wherever there is t, you should put 0. So this is the polynomial. This is the polynomial P of t. Wherever you have t, you should use 0. Not in k, not where there is k, you should put 0. No. Wherever the variable t, use 0. So write k as it is. 0 square 0 minus 2 is equal to 48, right? And work the and work this. You get the value of k. When you do this, you get the value of k. And now complete the polynomial. Use k and complete the polynomial. So P of t is equal to, use the value of k. And this is the polynomial for this person, Rita. think we have to select that. Yeah. Minus 24t square plus 24t plus 48. D. Correct? Is it C or D? D. Okay. Next one. A polynomial Q of t with sum of zeros as 1 and the product is -6 is modeling Anu's height in feet above the water at any time t in seconds. Then Q of t is given by. So to find Rita's polynomial, you were given the zeros. To find Anu's polynomial, you're given the sum of the zeros and the product of the zeros. So you should find the polynomial Q of t. Her polynomial is called Q of t. H of t, P of t, Q of t. Yeah. Sum of the zeros 1 and product -6. Sum 1, product -6, and it's Q of t. So what's the standard form? T square minus sum of the zeros. Sum of zeros into t plus product of zeros. T square minus x square minus sum of the zeros into x plus the product of the zeros. If you're given the zeros, you can find the factors and multiply. If you're given the zeros, then you can find the factors and multiply the factors. If you're given the sum in product, you can use the standard form. T square minus sum of the zeros into t plus the product of the zeros. Of course, k into. So it'll be t square minus sum of the zeros. So minus 1t. So minus t. Minus 6. Correct? Correct? So this is the polynomial that represents Anu's model. Okay. Now, again, this is incomplete. It's not complete. You don't know the value of k. You'll have to find the value of k. K into t square minus 6. No, that option is not there. So you have to find the value of k. So again what? T0. So that means Q of t is the polynomial. Q of t is the polynomial. When t is 0, see here how to write. Okay, when t is 0, Q of t, right? When t is 0, what's the value of Q of 0? 48. This is how you write. When t is 0, the answer is 48. The value of the polynomial is 48. So how do you find Q of 0? In the polynomial, wherever there is t, use 0. So k into wherever there is t, 0. Yeah, so what do you get? Minus 6k is equal to 48. K is equal to minus 8. So the polynomial Q of t is equal to minus 8 into t square minus t minus 6, which is minus 8t square plus 8t plus 48. Minus 80 square plus 80 plus 48. Yeah. Finished? You don't want that fan also? So which is this option? Is it option C? Minus 80 squared plus 80 plus 48. Yeah, option C. I'll share this image with you on WhatsApp. The question image. Huh. For the no, which one? Which one? Fourth one, huh? In 3, yeah, in 3. Yeah, correct. Where, which one? Can I just finish this and come back there? Yeah. Yeah, the last one I'll do it here itself. The zeros of the polynomial R of t is given here are negative of each other. Then the value of k is. When the zeros are, when one zero is the negative of the other, then this I think you can do it.
Ma'am,
Yeah,
answer I got is 3.
3. Yeah? Okay.
K is 3, ma'am.
Okay. So when the zeros, when one is the negative of the other, the sum of the zeros is 0. One is a negative of the other. So if one is alpha, the other one is minus alpha. Let the zeros be alpha and minus alpha because it's given the zeros of the polynomial are negatives of each other. So that means if one zero is alpha, the other one is minus alpha. So then what will be the sum of the zeros? It will be 0. See, if 1 0 is 5, the other one is minus 5. So what is the sum of the zeros? 0. So when 1 0 is a negative of the other, the sum of the zeros is always 0. When 1 0 is a negative of the other, when one is 6, the other is minus 6. One is minus 7, the other is plus 7. Or one is root 7, the other is minus root 7. The sum of the zeros is 0. So let the zeros be alpha and minus alpha. So alpha plus minus alpha, what is it? 0. The sum of the zeros. So that means minus b by a is equal to 0. Because sum of the zeros is minus b by a is equal to 0. So minus b by a. So that is minus k minus 3. It is in the standard form. Yeah, it is in the standard form. So minus B by A is equal to 0. K minus 3 is equal to 0. K is equal to 3. Yeah. So when the zeros are reciprocals of one another, alpha and 1 by alpha. So then there you should take the product of the zeros. If one zero is a reciprocal of the other, then let the zeros be alpha and 1 by alpha. Alpha into 1 by alpha, the product of the zeros will be 1. So C by A is equal to 1. C by A is 1. The zeros are negatives of each other. So we take alpha and minus alpha. When you add them, you see the sum is 0. When you add the zeros, the sum is 0. That means minus B by A is 0. This is A. The coefficient of t square is A. The coefficient of t is B along with the sign. And this is the value of C. Minus B by A. When you work that, you get K is 3. Taken? Yeah. Now tell me. Okay. Is that fine, children? Online students? Any questions, online students?
No doubt.
No, ma'am.
Okay. I just want to work the first and the second one again. Turn it off. Huh? Okay. Yeah. So what have we understood? This is the polynomial that represents Annie's, models Annie's parabola. And the two things that are connected here are time and the height. Time and the height, right? Time along the x-axis, height along the y-axis. Time along the x-axis and height along the y-axis. Okay. So now since the diving board is at a height of 48 feet above the surface of the water, the diver at any point has to start from the diving board, right? So she's standing there. So when time is 0, her height is 48 feet. When t is 0, her height is 48 feet. Okay. So to find the value of k, so this is the polynomial that models Annie's parabola. So to find the value, the first question is to find the value of k. So what we understand is her polynomial is called h of t. Annie's polynomial is called h of t. H of t. All right. So h of 0, that is when t is 0, time t is 0, h of 0 is equal to, when you give a value for t, you will get the height. When you give the value for t, you will get the height at that time. So when t is 0, what is the height at this time? 48 feet. So h of 0 is equal to 48. This is what we need to understand. H of 0, h of t represents Annie's parabola. So in h of t, when you take t as 0, time we have given, right? So the output, the answer should be her height at 0 seconds. And at 0 seconds, her height is 48. So this one you should write h of 0 is equal to 48. Why h of 0? Because h of t is Annie's parabola. H of t. So when time is 0, when time is 0, you should get the answer as height. The height is 48 feet. So h of 0 is equal to 48. If you write this, then everything is easy. So how do you work h of 0? This is only h of t. So h of 0 means here, wherever there is t, you must put 0. So minus 16 into 0 square plus 8 into 0, correct? Plus k is equal to 48. In this one, wherever there is t, you should use 0. Then you can find the value of k. So that's how we found the value of k. And then after finding the value of k, you should complete Annie's quadratic polynomial. Use the value of k here. Use the value of k here. See here. Once we found the value of k, h of t is minus 16t square plus 80 plus 48 plus k. No, so plus 48. We should use this for further calculation, not that plus k. Then the second question, at what time will she touch the pool, the water in the pool? So there we know that the height is 0. Height is 0 means h of t, we don't know the time. We don't know the time. At some time, her height is 0. The second one, we're always talking about time and height, time, height, time, height. When her feet touches the surface of the water, we know the height is 0. At what time, that we don't know. So the polynomial is h of t. Time I don't know. H of t. T we don't know. But the answer is the height, which is 0 feet. That we know. So h of t is 0. H of t is 0 means h of t is this one. So minus 16t square plus 8t plus k, I told you, 48 is equal to 0. So when you work this, you'll get two values for t. It's quadratic, right? So you'll get two values for t. The negative one you leave and the positive one, because time cannot be negative. So t is 2. T is 2. So her feet will touch the surface of the water in 2 seconds. In 2 seconds, her height will be 0. Is it fine? That's what we did for the second one. That's what we did for the second one. Yeah, continue. Then next one, another person, Rita, her zeros were given. So using the zeros, you should find the polynomial. And her polynomial is called P of t. P of t. So how did we find her polynomial using the zeros? We used the zeros when we found the factors. So if minus 1 is a 0, t plus 1 is a factor. If 2 is a 0, t minus 2 is a factor. Take the opposite sign. And the product of the factors into k will give you Rita's polynomial, which is P of t. Then again, we had to find the value of k. This is the third one. This is the third one. Zeros were given. Okay. Now we have to find the value of k. We have to find the value of k. So her polynomial is called P of t. I hope all of you are listening. It's called P of t. All right. So we know when t is 0, time is 0. Board. When time is 0, the height is 48. Correct? P of t. T time 0. P of 0. Time. When time is 0, the answer should be the height. The height is 48. So P of 0 is 48. P of 0 is 48 means in P of t, wherever there is t, you should put 0. So here, see k into 0 square minus 0 minus 2 is equal to 48. When you work that, you get the value of k. And once you get the value of k, put it in the polynomial here and construct the polynomial completely, P of t completely. That's the third one. And in the fourth one, we were given the sum and the product of the zeros. We were given the sum and the product of the zeros. Okay, so again, we have a standard form like this, k into t square minus sum of the zeros into t plus the product of the zeros. X square minus sum of the zeros into x plus product. Correct? This is standard form. So there we, like that, we constructed the other person's polynomial. And again, we had to find the value of k. And that was called Q of t. Q of t. So Q of t means when t is 0, when time is 0, everybody's height is 48 only. So Q of 0 is 48. Q of 0 is 48. So Q of 0 means here you should put 0 and find the value of k. And put the value of k here and get the quadratic polynomial completely. And the last one was different. The last one was if the zeros are negatives of one another, find the value of k. All right. Okay. Oh, you asked me to turn it off, right? 1 second. Yeah, go for this. Yeah. Yeah, please try this one, children. Okay, x is equal to minus b plus or minus root of b square minus 4ac by 2a, right? Now, when will the quadratic equation have rational roots? Rational roots. When will it have rational roots? When will it have irrational roots? Okay, so now rational, irrational is determined by this part of the formula. Okay, whether the roots are going to be rational or irrational is determined by this part of the formula. That is this expression root of b square minus 4ac, right? Which means the value of d. This is root d, so the value of d. So if d is a perfect square, if d is a perfect square, What is b square minus 4ac? D. If D is a perfect square, so like b square minus 4ac is 25. So it will be plus or minus root 25. So it will be plus or minus 5. Correct? Plus or minus 5. So depending on the value of b square minus 4ac, depending on the value of b square minus 4ac, you can decide if the quadratic equation has rational roots or irrational roots. You have such questions here. Yeah. What if d is less than 0? No real roots. D is equal to 0. Equal roots. D greater than 0. Unequal roots. Huh? Distinct real roots. Yeah. Unequal real roots. Correct. Yeah. Try this. Yes. Yeah, so these are the conditions. You all know this. Rational, irrational. If D is a perfect square, rational. If it's an imperfect square, it's irrational. Got the answers?
Done, ma'am.
Yeah. First one, which is the correct option?
A, ma'am.
A. Okay.
D.
First one A, is it? All of you? Here? Okay. Next. B. Okay. Next. B. A. Next.
B, ma'am.
B. Next. Next.
A, ma'am.
A. No. First one, all of you getting the same thing? First one? Okay, all of us get the same thing for the first one. Second one? Only in B, D is a perfect square, is it? D is a perfect square only in B?
Yes, ma'am.
Okay. For rational roots, D must be a perfect square because D is under the square root. Square root of B square minus 4AC, square root of D. So D should be a perfect square. Then rational roots. If D is an imperfect square, supposing 30, root 30 is root 30, right? So then it will be irrational. The roots will be irrational. Okay, so if D is a perfect square, the quadratic equation will have rational roots. So B, all of you say B for second one. Third one, A, all of you? Arjun? What about the others? Third one, all of you getting the same option, A?
Ma'am, I got it as C.
C. Check. B square minus 4. Check all of you. Okay. For this one, what's the value of D here, children? Tell me the values of D. What's the value of D here? Minus? Girls, what's the value of D? Minus 15, correct. What's the value of D here?
1,
Oh,
ma'am.
this, huh?
1, ma'am.
1, ma'am.
17, yeah. Okay, because we got minus 15 here, we stopped, is it? Oh, all right, okay, fine, okay. Then let me go to the next one then. Okay, for the second one, what's the value of D here?
1, ma'am.
Okay, then. Next one. Children, no, we cannot
One,
spend
ma'am.
so much time on this.
Ma'am, B is 1.
B is 1. A is minus? No, I'll tell you one thing. We'll not spend so much time on this one. This is the idea because you decide which the right option is. You know how to decide. You know how to decide. No real roots, D less than 0, you know. Rational roots, the value of D should be a perfect square. Irrational roots, the value of D should be an imperfect square. It should not be a perfect square. Equal roots, you know D is 0. Distinct roots, D greater than 0. So you know the criteria based on which you have to decide. Let me. Because I don't have the correct answers. Yeah, now maybe one, just tell me now for the first one, what's the right option you've got here? A. Second one? B. Third one?
C, ma'am.
C. Okay. Fourth one?
B, ma'am.
D. Okay. D? Okay, then? A. Okay. Okay, fine. This is what I've got from most of us. Okay, next one. My answer is right for the first and second one. Correct? Okay. Now for 3, which of the following quadratic equations has equal and opposite roots? Equal roots, but opposite roots. So should you work, or without working, we can just have a look and answer? We have to work. Yeah. Both A and B. Both A and B. You don't have to work, because if the roots have to be equal but opposite in sign, then that middle term x should not be there in the equation. The middle term should not be there. The middle term x, the x term should be missing. Only if the x term is missing, the roots can, be the same with opposite signs. Because it's like this, x squared minus 4 is equal to 0. So x squared is equal to 4, x is equal to plus or minus 2. In the second one, 16x squared is equal to 9. X squared is equal to 9 by 16. So x is equal to plus or minus 3 by 4. So if the x term is absent, see your x square and constant, x square and constant. So when the x term is absent, the equations will have equal and opposite roots. So both A and B. Both A and B. You can solve and check if you want. X squared minus 4 is equal to 0. X squared is equal to 4. X is equal to plus or minus 2. So you can see equal roots, but opposite signs. The second one also, 16x squared is equal to 9. X squared is equal to 9 by 16. X is equal to plus or minus 3 by 4. So equal roots, 3 by 4, 3 by 4, but plus 3 by 4, minus 3 by 4. So both A and B. This one, just expand this one. Expand this and see which you're getting.
C, ma'am.
C, yeah? Okay. And the last one? If one root is 1 plus root 5 by 7, the other one will be 1 minus root 5 by 7. Because it's plus or minus, no? Minus b plus or minus root b square minus 4ac, plus or minus. So if one is 1 plus root 5 by 7, the other one should be 1 minus root 5 by 7. See, if one root is minus 1 minus root 5 by 7, the other one will be, only this sign you should change. The other one will be minus 1 plus root 5 by 7. Don't change this sign. Only this one before this root, minus root 5 plus root 5. That's all. Only that change you should make. Minus root 5, so it will be plus root 5. The others will be the same. If one root is minus 1 minus root 5 by 7, minus root 5, the other root one, sorry, if this is one root, the other root will be, this minus root 5 will become plus root 5. That's all. Only this change you should do. Just change the sign in front of that irrational value. Okay. Fourth one. A minus b the whole square. A square minus 2ab, no? So it will be minus 4x only. a square x the whole square minus 2 into a into b. You have written plus 2 into a into b. X minus 2 the whole square. When you expand, x squared minus 4x plus 4. X squared minus 4x plus 4 plus 19. And this one is 23. So x squared minus 4x plus 23 is equal to 0. Okay, this is more theoretical, so let's just do this together. If p of x is a quadratic polynomial, if p of x is a quadratic polynomial, ax square plus bx plus c, a not equal to 0, then p of x equal to 0 is a quadratic equation. Yeah, if the quadratic polynomial is equated to 0, it's called a quadratic equation. When a quadratic polynomial is equated to 0, p of x is a quadratic polynomial. When it's equated to 0, it's called a quadratic equation. This one is the quadratic polynomial, and this is called p of x. So p of x is the quadratic polynomial. When the quadratic polynomial is equated to 0, it's called a quadratic equation. Yeah. Answer the first one. Read and answer the first one.
D.
D. B or D? D.
D, ma'am. D.
D. Oh. Okay. Here. D. A, B, C are real numbers and A should not be equal to 0. The coefficient of x square, A should not be 0. And A, B, C can be real numbers, not only rational. They can be irrational also. A, B, C are real numbers. And here it is A, B, C real numbers, C not equal to 0. No, no. The coefficient of x square, A should not be 0. And A, B, C all can be real numbers. So option D. Then the degree of a quadratic equation is 2. This you try and tell me. We'll do the fourth one. Which of the following is incorrect about the quadratic equation ax square plus bx plus c equals 0? Which one is incorrect? If a alpha square plus b alpha plus c is equal to 0, then x is equal to minus alpha is the solution of the given quadratic equation. Let's understand this better. See, if a into 3 square plus b into 3 plus c is equal to 0, then x is equal to 3 only is a solution, no? In place of x, you're using the, what are the zeros of a quadratic polynomial? Alpha and beta, right? A quadratic equation, alpha and beta. So in place of x when you use alpha, in place of x when you use alpha, ax square, in place of x, use the root alpha, then plus bx, b alpha, plus c equals 0. That means the root is alpha, right? X is equal to alpha and x is equal to beta, but they've given x is equal to minus alpha. It's wrong. What are the zeros? What are the roots? X is equal to alpha, x is equal to beta. X is equal to alpha, x is equal to beta. So in place of x, you can use beta also. A beta square plus b beta plus c is equal to 0. Alpha and beta are the roots. That means x is equal to alpha, x is equal to beta. Alpha and beta are the roots. X is equal to alpha, x is equal to beta. So when you're substituting for x, it will be a. For x, you can use alpha, alpha square plus b alpha plus c is equal to 0. Now with alpha and beta, to construct the polynomial, then it is x minus alpha into x minus beta. To construct the polynomial, we'll take opposite sign. The factors will be x minus alpha into x minus beta. Because if x is equal to alpha, then when you transpose x minus alpha is equal to 0. You understand that? Okay, so this is incorrect. This one is incorrect because x is equal to alpha, not minus alpha. The additive inverse of zeros of the polynomial ax square plus bx plus c is the roots of the given equation. Okay. The additive inverse of the zeros of the polynomial, this one, is the roots of the given equation. See, zeros and roots are the same actually. Zeros and roots are the same in the sense, we say zeros of a quadratic polynomial. The same thing we say are the roots of a quadratic equation. Okay, let me just write that. See, quadratic polynomial, quadratic equation. Okay. When we say quadratic polynomial, we say zeros of a, okay, we say zeros. For the quadratic equation, we say roots. But the values are the same. The values will be the same. When we use the term quadratic polynomial, we say zeros of a quadratic polynomial. 1 and 2. 1 and 2 are the zeros of the quadratic polynomial. But when we say equation, we say 1 and 2 are the roots of the quadratic equation. All right, so this is incorrect. But what they are saying is additive inverse meaning negative. Additive inverse is the negative of a number. The additive inverse of 5 is minus 5. The additive inverse of 5 is plus 5 is minus 5. Minus 5 is plus 5. Okay. No, it's false because it's just that the values don't change. When we say quadratic polynomial, we use the term zeros. When we say quadratic equation, for the same numbers, we say roots. For the same numbers, we say roots. 1 and 2 are the roots of the quadratic equation. Or 1 and 2 are the zeros of the quadratic polynomial. But numbers are 1 and 2 only. Yeah. So this is also incorrect. This one is also incorrect. Then if alpha is a root of the given quadratic equation, then its other root is minus alpha. So that we can't say. If one root is alpha, the other root is not minus alpha. That's right. If one root is alpha plus, like, okay, give me an example. I'll give you an example. If one root is 2 plus root 3, yeah, then the other one is 2 minus root 3. But they are saying if one root is like 5 by 4, the other root is minus 5 by 4. No, that we can't say. If one root is alpha, the other one is minus alpha. That means if one is 5 by 4, the other one is minus 5 by 4. No, that's not. That may be, but not always. So that means I think all of these are incorrect. The question is, which of the following is incorrect? All are incorrect. All are incorrect because this one is incorrect because x is equal to alpha. X is equal to alpha, it should be. So it's incorrect. And this one, they're saying that the zeros and roots, they're negatives of one another. What it means there is in B that the zeros and the roots, they're negatives of one another. No, they're the same. Zeros, roots, both are the same. For polynomial, we say zeros. For equation, we say roots. But the values are the same. So that's also incorrect. And if one root is alpha, the other one is minus alpha. Maybe sometimes, but not always. So that's false. So all are incorrect. The correct option is all of these. Last one, which of the following is not a method of finding solutions of the given quadratic equation? Not a method. Factorization method is a method. Comparing square is a method. Formula method is a method. So none of these. None of these. Because which of the following is not a method? No, only methods are given. Not a method is not at all here. So none of these. Yeah, please work the third one and tell me. Please work the third one.
The third one is A.
Okay. Yeah, others please work. Finished working. All right. Some of us say A, you finished? Got it? Okay. These, I think these images I'll just share with you children. It's just about finding zeros, I think. Yeah. For what value of n, 4 to the power n ends in 0? So when can 4 to the power n end with the digit 0, or when can anything end with the digit 0? It should have 2 and 5 as factors. Yeah, it should have 2 and 5 as factors. So 4 to the power n is equal to 4 is 2 square. So this is nothing but 2 raised to the power 2n. So what we understand is this prime factor 2 happens 2n times. The power says how many times, right? The power says how many times the base is multiplied with itself. So 2 to the power 2n, meaning the base 2 happens 2n times. So 2 only happens many times. 2 into 2 into 2 into 2. 2 happens many times. So since we don't have 5 in the factorization of this expression, 4 to the power n cannot end with the digit 0, because for an expression to end with the digit 0, it should have both 2 and 5 as factors, because 2 5s are as 10. Okay. So for what value of n, 4 to the power n ends in 0? No value. When n is odd, even, no. Whether n is odd, even, whatever it is. 4 to the power n, this is what you should be writing, is 2 squared, the whole power n, which is 2 to the power 2n. This means the prime factor, which is the prime factor here? Only 2. The base is 2. So this expression has only this prime factor 2 happening 2n times. So there is no 5 at all. So this expression cannot end with the digit 0 because it does not have 5 as a factor. Okay, no value of n. Next one. It looks very crazy. Okay, so a positive rational number and positive integer. Anytime, no? So see, for all n greater than 1, Whenever n is greater than 1. Nothing, there's meaning nothing much to think. A is a positive rational number. A is a positive rational number. And n is a positive integer greater than 1. So just take an example like supposing 1 by 2 is a rational number. And n is any value greater than 1. Any value greater than 1, it can be 2, 3, 4, whatever. Then for what value of n, a to the power n is a rational number. So n can be any value. For any for a to the power n to be a rational number, n can be even or odd. For something to be a rational number, the power can be even or odd. So like 2 to the power 3, 8, 2 to the power 4, 16, rational. Or say like 3 by 5 to the power 11 will be rational only. 3 by 5 to the power 12, rational. A is a rational number and n is an integer greater than 1. A is a rational number, just A by B. Okay, it's a rational number. And n is greater than 1. It's a positive integer greater than 1. For what value of n, a to the power n is a rational number. So, but the base is a rational number. The base is a rational number. The power is anything greater than 1. Because it's given no, see here. N is a positive integer. Positive integer meaning it's greater than 0. N is greater than 0. So now when will this be a rational number? Actually, there's nothing much to, like talk about this. It will always be a rational number. For whatever power, a by b, whatever base you take and any power, it will always be rational. I can just give you examples. If you take a rational number 2 by 5, raise it to the power 3, it's odd, but the answer will be rational. The same thing 2 by 5, when you raise it to the power 4, which is even, it will be rational. Why we are taking 2 by 5? 2 by 5 is a rational number. And power, it's given positive and greater than 1. So like 2. 2 by 5 to the power 2. Will it not be rational? Yes, it is rational. So if it is even, it's rational. What if it is odd? It will be rational. A rational. So I see it. A rational. So just take something. N positive greater than 1. So I just took 2. And they're talking about a to the power n. A to the power n. This is a. 3 by 7 is a. To the power n, 2. Now, is this rational? Yes, it is rational. If this 2 is 3, it is rational. If this 3 is 13, it is rational. For whatever power, it will be rational. So for all n greater than 1. Next one. If x and y, here for all n greater than 1. If x and y are two odd positive integers, x and y are two odd positive integers, then which of the following is true? Okay. So just take an example. That's all it is. So two odd positive integers. Okay, so 1 square plus 3 square. 1 square plus 3 square. See it. Take the definitions. X and y are two odd. They're positive, they're odd. They're positive, they're odd. So 1 square and 3 square. All right. So 1 plus 9, 10. What is 10? What are the options here? It's even, odd, not divisible by 4. Okay, so it is even, but it's not divisible by 4. Take another example, 5 square plus 7 square. 5 square is 25 and 49. So 14, 1 carried over, 74. 74 is even, but it's not divisible by 4. No, we are just using the options. It's not odd, it's even only. See, it's even, it's not odd. Based on the options we are talking, even, odd, not divisible by 4. So we're using these and trying to understand. X and y are odd. So we first took 1 square and 3 square. We got 10. 10 is even and it's not divisible by 4. Not divisible by 4. Then 3 square plus 5 square. 3 square is 9. 5 square is 25. So what do you get? 34. 34 is even, but it's not divisible by 4. So 1 or 2 examples is enough. Both A and B. It is even. X square plus y square is even and it's not divisible by 4. So both A and B. One out of every 3 consecutive positive integers is divisible by 3. Yeah. Sorry? Always true. Yes, it's always true. Because if you take any 3 consecutive numbers, one of it will always be divisible by 3. The last one, if n is any odd integer, then n square minus 1 is divisible by. N is odd. Okay. Okay, so
8.
yeah, correct. N square minus 1. N is odd. Okay, n square minus 1. So let's take n as 1. N is odd. Okay, so you cannot take 2. N is odd. So 1. 1 square minus 1 is 0. And 0 is divisible by 8. 0 by 8 is 0. 0 is divisible by 8. Okay. Then n square minus 1, say 3 square minus 1. 9 minus 1, 8. 8 is divisible by 8. Correct. Then let's take 5. 5 square minus 1. 25 minus 1, 24 is divisible by 8. So when n takes any odd value, n square minus 1 is always divisible by 8. Is always divisible by 8. This one always true. Here, when we took examples, we understood that it's always even and divisible by and not divisible by 4. Okay. Yeah, do this one. Nothing much in the passage there, I think, children. So you can just start from here. Okay, so for the first one, HCF or LCM? LCM. Okay,
LCM.
for this LCM. For the second one,
HCF. ma'am.
HCF. Okay, fine. Please continue. Yeah. Yeah, what's on answer for the first one? B. Okay. Then second one?
C, ma'am.
C. Okay. Third one? C.
C,
ma'am.
ma'am.
Okay, very good. Okay. Then fourth?
D, ma'am.
B. B. Still to do. Okay. So 8 meters, 25 centimeters. Convert that to centimeters. So it will be 825 centimeters. Then 675 centimeters. Then 450 centimeters. And find the HCF. The last one? Okay. So the LCM of 8 and 12 is 24. For the last one, the LCM of 8 and 12 is 24. So if you want to buy equal number, if you want to buy equal number of pens and notebooks, you should buy the minimum quantity you should buy is 24. In the last one, if you have to buy equal number of pens and notebooks, what is that minimum number you should buy? So the minimum number is the LCM 24. Minimum LCM 24 you should buy. Okay, but 24 you will buy. Pens are sold in packs of 8. So you should buy 3 packs because in 1 pack 8. So 3 packs 24 you'll get. So pens you must buy 3 packs to get 24. And then notebooks in 1 pack 12 books. So 2 packs you'll buy. 2 packs. So 3 and 2. The last one is in 1 pack there are 8 pens and in 1 pack there are 12 notebooks. What is the minimum quantity you should buy so that you have equal in both? You have equal number of pens and notebooks. Equal number of pens and you have to buy equal number of pens and notebooks. So what is the LCM of 8 and 12? 24. So that's the minimum quantity. That's the minimum quantity you should buy. So 24. 24 means how many packs of pens? 3 packs. And how many packs of notebooks? 2 packs. That's what is they're the options given here. 3 and 2. Three packs of pens, so 24 pens. 2 packs of notebooks, so 24 notebooks. And 24 is the LCM of 8 and 12. Yeah, do this one. I will try this one. Oh, it's time, huh? It's deleted, huh? Okay, others here, this topic has been deleted, is it, from the syllabus? Online students? This is time factorization only, no? So, online students, yes or no? Deleted. Okay, sorry then, I wasted your time. We'll just answer the first one and stop. So we'll do this together. What is the HCF of X and Y?
P square Q, ma'am.
P square Q. Correct. P square Q. What's the LCM of X and Y?
P square, P cube, Q cube, ma'am.
Correct. P cube, Q cube. Now, there is something given. See, like from the options, you know, what you understand is, see, from the options, what we understand is, it's given. Okay, I think when I say find HCF by LCM or LCM by HCF or find LCM, see, that's what is given. Now, see, if you bring this down here, if you bring this here, HCF by LCM is PQ square. Bring this down here. LCM by HCF is P square Q. Options are given like that. LCM by HCF. You understand that? Yeah, so we'll also just find HCF is equal to P square Q. LCM is, so we'll just find HCF by LCM is equal to P square Q by P cubed Q cubed. So what do you get? 1 by PQ square. So you get LCM is equal to PQ square into HCF. Correct? When I do HCF by LCM, I get 1 by PQ square. So when you cross multiply, LCM is equal to PQ square into HCF. Agree, all of you?
Yes, ma'am.
Okay. See, we divide because there's not an idea or something. Based on the options, we understand that, okay, let's just divide one by the other and cross multiply to get an option, to get, you know, an option, meaning an answer which looks like the options here. All right. Okay, now, apart from this case study and, assertion raising questions, is there any particular chapter where you feel like that's very difficult or, you know, which you think you need more, you need more practice, sorry, where you need more practice, or we'll do assorted questions on Saturday? So nothing specific you have. Statistics. Okay. Triangles. So we'll revise the trigonometry.
Heights and distance, ma'am.
Heights and distances. Okay. All right. Yeah. So then Saturday I'll collect questions from the chapters I heard now, similar triangles. Okay, we'll do that. All right, online children, that's it for today's session. Thank you so much. You may leave the class. Thank you, children.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children. Thank you.